Good morning, everyone. May I have your attention, please? This is the captain speaking from the bridge. Welcome to my YouTube channel. Our topic for today is about finding the GHA, LHA, and the true azimuth of sun using the ABC azimuth table. But before we continue to our topic, yung mga bago pa lang sa ating channel at hindi pa nakapag-subscribe, please don't forget to touch the subscribe button para lagi tayong updated sa mga video nating ina-download. So let's start now to our topic. Finding the GHA, LHA, and the true azimuth of sun using the ABC azimuth table. Let's say that the date is August 13 and time 1500 hours, 20 minutes and 16 seconds. The position is latitude 25 degrees and longitude of 120 degrees. In order to obtain the GMT time, we will subtract the zone description to the local time. So 15 hours minus 8 is 7. Then the 7 hours is used in finding the GHA in the almanac here. So tingnan natin, we'll see on the August 13. So August 13, here is the August 13. So the value of 7 hours is 283 degrees, 48 minutes north. And the declination is 14 degrees, 30 degrees, and the declination is 14 degrees, 30.4 minutes north. Now, the minutes in time and seconds should be checked, should be look the value of 20 minutes and 16 seconds in the increment table. So here is the increment table. So 20 and 16. And the value of that is 16 is 5 degrees 04 minutes north. So i-add natin yon. The value of that will be the true GHA. The value of 7 hours in GHA table plus the value of minutes and second in the increments table, the result will be the true GHA. So 283 degrees plus 5 degrees will be 288 degrees. Then the minutes is 52. Now, in order to come up to the local hour angle, so we will apply the longitude. So the longitude, if your longitude is east, it should be added to the GHA in order to come up to LHA. Now, yung GHA natin is 200. Yung GHA natin is 289, rounding off number. So, yung longitude natin is 120. So, 904. So, the LHA, the result of LHA is 409 degrees. Since 409 degrees exceeding to 360, so we will subtract this one, the 409 by 360. So how much? We have a declination that we also needed in finding the true azimuth using the ABC azimuth table. So the declination is 14 degrees and 30.4 minutes north. So the correction, the decorrection is 0.8. So titingnan natin, we will check also in the increments table what is the value of decorrection and table increments. So that the value of that is 0.3. So the total declination is 14 degrees 30.7. So 0.7 is very minimal. So we will use the 14 degrees and 30 minutes north and locating and finding the true azimuth of sun using the Norris table by ABC azimuth table. The LHA will be the sum of GHA plus or minus the longitude of observer. The GHA is always west of meridian. So I will project to you prime meridian. Okay. Now, our longitude is east. So this one is east and this one is west. So from here, we will draw going here, and that is approximately degrees east. Okay, yan this is the longitude. And as I mentioned that the GHA is always west of the meridian. Our LHC is 288. So from here, going here is 180. So still rotating. So somewhere here. This is the GHA. GHA. Now, this is 400. This one is 409. So, since no 409 in the compass is only 360. So, we will subtract this one by 360 in order to come up the local hour angle. So, the local hour angle is this one. From the latitude, from the longitude, the local hour angle is from the longitude to here. Okay, so again, the GHA Greenwich hour angle is always west of the meridian. Okay, so that is why we come up to 49 degrees LHA. ABC azimuth tables, these tables can be used Number one, in all latitudes between 80 degrees north and 80 degrees south. And for all declination between 75 degrees north and 75 degrees uh, south. A is entered with the argument of local hour angle and the observed latitude. Meaning, it is the intersection. You know, because on top of the table is you can find the local hour angle. And on the side is the uh, observed latitude. Now, projecting the imaginary line from top to bottom and from left to right, the intersection of that imaginary line will be the value of A. And the name of the A is always opposite to the latitude, except when the local hour angle is in between of 90 degrees and 270 degrees. Okay, now the table B is also the argument of local hour angle and the declination. Now, same as on table B, same as on table B, you project an imaginary line from top to bottom and from left to right, and the intersection will be the value of B. And the name is always same as declination. Now, the value of C is the sum of A and B and the observer latitude. Now, A and B, same name should be added as a result of C. You add A and B, and the result is C. And whichever the greatest value of A and B, it should be the name of C. If the body is east of the meridian, the LHC is between 180 degrees and 360 degrees. Using the ABC table, the value of A is 0.41 south because the name of A is always opposite to the latitude, except when the LHC is in between 90 degrees to 270 degrees. The value of B is 0.33 and the name of B is always same as to declination. So we have the north declination. So that is why the name of B is north. Now A and B is greater than B. So 41 minus 33 is 8 south because the greater is A, which is the name is south. Now, the value of C, it is also the intersection of the value of A and B on top, and on the side is the observer latitude. O, tingnan natin dito. Yan. Ito. Now, our latitude is 25 degrees. So, from left to the right, straight line. And from top to bottom, straight line, and the intersection of that is 86.4. So 86.4 degrees, 6.4, and the name is south. So the azimuth is north or south depending on the name of C, and E, S or west depending on the value of the LHA. So since our LHA is 49, so the body is on west meridian. So now, so this value 86.4 is south, 86.4 west. So paano natin makukuha ang true azimuth ng sun? So sinasabi dito, south, 86.4 west. Meaning, you will measure 86.4 from south going the west. So how much the result? So south is 180 degrees. So you will add 180 degrees to 86. You will add 86.4 add by 180 degrees. So how much? 4, 6, 6. So the true azimuth of the sun is 266.4 degrees. So this is the true bearing of the sun when you took the bearing. Now this computed azimuth bearing of the sun should be deducted to the observed bearing during the time of 1520 minutes and 16 seconds. And the difference of that will be the gyro error. Let's say the observed bearing is 270 and 266 yung true, 0.4. And you subtract for that, 10 minus 6 and 9 minus 3 is 3. What is the name of the gyro error? So the rules is compass best, error west. So since the compass is greater than the computed azimuth bearing, so the error is 3.6 will be west because of the rules that compass best, error west. So thank you very much watching my video. I hope that you enjoy and learn something. And our next topic will be the computation of sunrise, sunset, and that is what we call the amplitude of the sun. Thank you very much. Have a nice day.